On this episode, I speak with Ben Gibbons and his startup Circular 11, which is creating new methods for tackling one of the hardest problems in the recycling field, namely recycling difficult to sort mixed plastic into products such as plastic lumber, which have a wide variety of building uses. In the discussion, we got into detail about the recycling process, the true carbon emissions of recycling, taking into account the energy use. And if you listen to the end, we even talked about the £1 million question: should we be buying any form of plastic product? We began by discussing how Ben started Circular 11.
First of all, thank you very much for having me. And yeah, delighted to talk about it. Um, Circular 11 started about 4 years ago. We were a lockdown baby, and we originally came out of a waste management project in Nepal where me and my co-founder were working, because my background is in international development, and we were working on waste management projects. Um, and actually very, very different to what we're doing now, which is all machine learning and polymer science. It was on increasing the civic capacity of local organizations to do community-led recycling. But I was very frustrated with the efficacy, the effectiveness of some of the kind of initiatives that we were leading. And in short, it is a very technical and economic issue where recycling systems really need to work within market environments to be sustainable.
Mm,
And there are technical and systemic reasons why that's challenging. But we weren't getting to the core of the issue with some of the interventions. And I became very interested in waste valorization technology from a slightly more technical perspective, thinking, why aren't these plastic recycling systems viable? Why isn't this material here getting recycled and this is, and so on and so on. And so that's where the germ of the interest came from. Um, and it was also a confluence of coming back to the UK, realizing that we have very similar challenges, many more similarities between emerging markets and developed economies, because our recycling rates are pretty low as well. And I'm not sure what would have happened in a counterfactual universe where COVID hadn't happened, but the loss of seemingly all development jobs all at once because of the contraction in the economy encouraged me to just make the jump and actually commit to some of the ideas that had been fermenting over the prior 2 years. And that's
yeah.
where the company started off from.
So because I know that your main product is this plastic lumber, these sort of yeah,
Yeah,
is that's the right term, isn't it? Sort of they look like planks, but they're made of
you
plastic.
got it. You got it
Is
great.
that related? How related is that to the sort of efficiency problem of or of the scale of production? Is that related to why you chose lumber, or is that sort of two separate things? Because presumably the lumber can be used for so many different things. How did you end up with that?
Yeah. So we originally started by trying to develop a building, an interlocking like wall fabric,
Mm,
basically something that could be used in kind of residential construction. And we spent about a year and a half developing a material and a kind of design that could lock in together. I normally say there are many reasons why that's a bad idea and it didn't work, but it created the context for us to kind of pivot and develop the technology. I've actually met someone recently who is running a very quickly growing company in Ethiopia who's doing exactly that. So he's proved me wrong and that it can be done. However, there were a number of very challenging things to developing a building product. It's scalable in some ways, but it's such a regulated market from a cash flow perspective. Also, the length of time between initiating potential contracts and getting paid is enormous, and it's got such a significant set of challenges. We realized that we were sitting on a problem that was, if anything, more uh, scalable, or a problem that was more systemic, and that's the problem of mixed plastic processing. So we wanted to develop these bricks out of lower value mixed plastics that couldn't be further separated. And actually, the technical challenge needed to try and uh, overcome the challenges of input variation, what's called input variation in plastics, where your plastic streams are quite mixed together. That was already extraordinarily interesting and challenging and presented a huge opportunity to improve the sector. And so we started to focus less and less on the end product and more on the manufacturing process. The reason why we went to lumber initially is because it's a very simple product, and therefore the emphasis isn't on the complexity of the geometrical mechanical design of the end product. It's on how we create that same standard as is needed to put lumber on the market with a lower and lower value of input if we need the output to still be whatever it was before. And so it was a simple application for us to deploy this manufacturing technology that we ended up developing. Um, that's the main reason. There are some small reasons also why lumber is quite useful. It's quite thick, which means that it's not quite as um, precise in its requirements as a really thin-walled product like piping. I won't bore you any more than that, but it's a good initial deployment of a novel manufacturing technology because its thickness allows you to get away with a little bit more than you do in very thin-walled applications. Um, and that's ended up being our mainstay. As you say, it's a high volume lumber material.
Yeah, and so many uses. I mean, there's just so many aspects that are fascinating about um, the recycling of plastic. But I wanted to ask about the sourcing. How does that work? Where do you get plastic from, and how difficult, how much of a challenge is it that sorting through all the different types?
So we tend to source from municipal recycling centres or national sorting centres. So the likes of that owned by Veolia and Suez, Viridor, these very big companies that collect household plastics, try and sort it using conventional separation technologies, and then they sell the high value plastics that they can separate off. They're always left with very large tranches of post-consumer material that can't be separated,
Mm.
and we'll take that directly from those sources. The point of the technology is that it's adaptive manufacturing. So we're developing intelligent manufacturing systems that adapt to post-consumer variation and therefore minimize the need to sort. So we tend to um, process pretty much what we're given. That doesn't mean we can do literally anything. Certainly, it has to be polymer. So we need to separate out things like loose metals that might be in there. And there are also some specialty polymers that we haven't trained our system to adapt to. So polycarbonates or ABS we haven't reached yet. However, we tend to source from household recycling facilities that don't really see a huge amount of those specialty polymers anyway. So the short answer is that there isn't an enormous amount of sorting involved. However, it is still a very complex challenge, and perhaps we can go into it. But
Mm.
processing those mixed varying ratios of plastics is something that creates its own set of challenges.
So am I understanding correctly that this is sort of like a niche thing that you're able to, or a specialty thing that you're able to take these mixed plastics as opposed to just getting the pre-sorted types?
Yeah, that's right. So if you look at the European market, because that has the best data, um, of the plastics that reach a recycling facility, if you take the most common household ones, excluding PET, so polypropylene, HDPE, I won't go into it any more than that. Um, Around 92% will end up going to waste from a recycling facility. Um, and the single biggest reason is because it's commingled. That's not something that has any value on the market the majority of the time. So, with some caveats, it can be sold to people who then extract the high value stuff. But at some point, it loses more and more and more of its value, and very large percentages are left, which don't have any value. So it is relatively novel to be using these streams. We don't know other manufacturers that process them. And the biggest leverage point for us as a business is that if it's a really valuable addition to the circular economy, that means that we tend to be dealing with materials that other people think are wastes, and therefore we are often
Mm.
able to charge a gate fee or to collect it for no charge. So that's the big differentiation with us as a business. From a customer standpoint, we have a slightly advantageous cost base. I guess you can say we have a slightly um, happier and lower cost of goods because we're able to take wastes, and that allows
Mm.
us to do things in the market that are slightly novel in terms of where we put the lump.
And most of what you receive, you're saying like the vast majority, you can just form into this end product, this lumber.
Yeah, that's right. And it's not as simple as 100% of this waste goes in and 100% of
Mm.
this end product comes out. It's a system where we have to appraise the individual qualities of specific input streams and understand how and where they can be put together. Every waste stream will have specific characteristics and ratios of plastics, which make it better for some things and slightly worse at other things. And that makes it a bit like a jigsaw piece that has certain shapes and certain things that it's good
Mm.
at and certain things that it's not good at. And we need to dynamically match that. The problem is if you try and do that using normal polymer science, it will take a very long time, and that's not appropriate for a live manufacturing environment. That's why we're harnessing a lot of machine learning to try and train our systems to do that in real time. Um,
Fascinating, fascinating. I've just got to ask about the sort of carbon situation, because obviously,
yeah.
unlike sort of petrol or fossil fuels, not all plastic ends up being incinerated. And I was looking at this World in Data report, how it was sort of going through, obviously, very little is recycled, not enough. And then a lot of it's going to landfill and lots of it's mismanaged. And then 19% it said was incinerated. Obviously, that was on a global level. How do you sort of think about, and when you're pitching to customers, the carbon benefits, do you look at sort of what's happening in the UK and what is that counterfactual if you hadn't recycled plastic?
Um, Great question, and not one that I get asked enough. It's a bit like energy and using renewable energy. If you want to work out the um, carbon impact of using X amount of electricity, you need to know what the makeup is of the grid at any one point in time. That's dynamic, but you have conversion factors, and so if there's a country with lots of solar, that electricity is going to be less carbon heavy. It's the same thing in recycling. It depends on the country, but we operate in the UK. And so we know this market environment most in terms of its carbon impact, about 50, between 49, 52%, something around that number is what we think is incinerated.
Mm.
But you can get more granular than that. It depends on what the source is of the plastics that you've taken. In general, um, plastics are a hydrocarbon. They're made from oil, and that means that people would incinerators would be normally keen to have them in as long as it doesn't have certain types of chemicals in them, including PVC. Um, and that means that on the whole, if it's a pure polymer source, as in it's gone to a recycling center, and it's not ended up in the residual waste rubbish bin, but it's actually gone into the recycling bin. That's gone to a recycling center. They haven't been able to process it. The share of that plastic that's incinerated is much, much higher. Um, Over the last decade, there's been a lot of regulation out of the landfilling of a kind of pure material like that. So we try and work with carbon assessors to say what's a realistic scenario for this,
Mm.
and it does depend on the source, but we build that picture up and
Do you
try
have
and
any
pass
stats
it
on
through
that?
some. The environmental product declarations that we have would say that on average from the current sources that we have, the net mitigation of carbon would be about zero point 0.5 tons of CO2 per ton of product.
Wow.
Um, if we increase the percentage of waste like we're trying to, that will get closer to a ton of CO2 per ton of product. That's
Mm.
our kind of target generally. Um, Net, including energy capture, if you just incinerate a ton of plastic, then you're normally looking between 1.4 to 2 tons of CO2 emitted. So it's called energy for waste, but we don't like it. It's not a very sustainable form of managing plastics. And
So
obviously
that,
we have our own footprint, and that's where our footprints
yeah.
come from.
Sorry. Am I understanding it right that that half ton that's after your
Yeah,
emissions are taken into account? Yeah.
that's correct. Yeah,
Right. Okay. So you're saving sort of 25% or something like that of the emissions, plus you get a new product out of it,
that's true.
something
Yes,
like that.
that's right. Um,
Amazing. Mm.
the counterfactual includes, just like you say, it means that we might be displacing closer to 1.5 tons to 1 ton,
Mm.
and then we minus our own electricity consumption from that. What's not included in the counterfactual is the energy consumption of the product that you're replacing, because you can get carried away in counterfactuals and say that you're replacing steel every single time. It depends on exactly where it goes to. But yes, that's the joy of the circular economy, that you also get a product that lasts longer and obviously would have had its own resource footprint.
Yeah. And I suppose, of course, it's important to remember that as you say on your website, the importance of reusing, reducing before before you do this. This would be seen as what a last resort, I guess.
Yeah, that's exactly right. That's exactly what it is. We know our place in the waste hierarchy, and sorting technology needs to be improved. Closed loop recycling needs to be improved. And there's a lot of very, very interesting innovation out there. I guess our thesis as a company is that there will always be tranches of mixed plastics because of the nature of recycling systems, and every single technique that exists um, has certain areas where it can't separate these kinds of plastics so well, or plastics have additives that affect the density, and therefore you can't separate them by density as easily, or so on and so on. We would love to see those percentages reduce, but it's not effective or realistic to refuse discussions about what we call open loop recycling, because of course you want closed loop recycling. And I feel like discussions within environmentally concerned areas are often um, sometimes in danger of being a bit black and white. It's about having a hierarchy of preference, but you often need to do everything at once. We're not going to eliminate mixed plastics, and that's where this kind of thing comes in. What we imagine ourselves as doing is trying to create a kind of circular open loop system, because once it's at this secondary layer, it's not a very thin walled film packaging application, it's a construction material. We can recycle this and anything similar to it, competitors' products or the like. We can recycle it many, many times before it measures a significant deterioration in performance. Um, the properties are just
So
not as
your products can
particular.
be recycled multiple times.
We can recycle our products multiple times.
Brilliant.
And so much of the effort needs to be, how do we make reverse logistics feasible? Yes, we will go and collect the products at end of life, but what if a customer doesn't take us up on it? Well, that's why we'd work with people like Travis Perkins or other centers where it goes. It's a whole another conversation about how reverse logistics needs to work, but it's absolutely essential that for complex materials, and this is a complex material, you need the manufacturer to be able to reprocess it. That's not a problem for us. But in this secondary layer, after it's been, let's say, demoted from a packaging application, we can hold it here for potentially hundreds of years in this use case. And therefore, the problem with open loop recycling is that the material value drains out so quickly. It cascades down from, a really high value polymer to a jumper to incineration. And if that's the chain, then of course open loop recycling isn't going to be associated with a circular economy. What we're trying to say is, well, a circular economy needs to be able to tolerate some open loop recycling. What does a circular sustainable system look like if it needs to be open loop? And for
Yeah,
us, that probably looks something like this.
I think it's so important and so interesting um, to hear those sort of solutions that you're providing to to the open loop problem. Um, but of course, it's even better than that in a way because if something was going to be incinerated and then it's not, and it's like fundamentally different from an emissions perspective as well, isn't it? Because if your emissions are contingent on energy, I assume mostly, and so when that becomes more renewable and the emissions drop from energy, then it drops accordingly. Whereas obviously incineration is just incineration of plastic.
Yeah, that's exactly right.
Um, yeah, what do you think then is the biggest sort of challenge that you're facing, um, or I say you, but in general with recycling plastic?
Um, there are two questions in there. There are a couple of major challenges with post-consumer plastics in general. Um, and there's a lot of work at a government level to try and reduce the challenge here, but um, there are a whole host of additives in recycled plastics, some
Mm,
of which are fine and easily dealt with, some of which aren't. A lot of what you see in electronic plastics, so stuff surrounded by, laptop plastics and washing machine plastics, they've often got legacy fire retardant additives that are not nice to deal with, and many of which are actively illegal to recycle. That places quite a high burden on the recycler for good reason. There's a reason why you're not allowed to put them into new products often because of the kind of research that's come out on their health impacts. But it means that you have to have very sophisticated techniques to try and detect it. So those kinds of challenges can be um, thorny and can rule out certain types of plastic from the realm of from the discussion. It's not even a question, we're not allowed to touch it. And um, phasing out additives which are going to really reduce the recyclability of plastics is a really important area of regulation. Um, the one thing I also have to say is the funding for recycling infrastructure at a national level
mm,
is really not government supported. And it's interesting. I was talking recently to a recycling company that has built a 50,000 ton a year facility for soft plastics. That would increase the UK's capacity by between 5 and 8%. It's a really significant volume if you look at the amount of material we have per year. Um, but there were some relatively minor issues during the build phase, which meant that there was uh, £2 million of extra spend, and they are unable to launch the facility. They need to do an extra 12 months worth of raising, and that is a rounding error on energy projects.
mm,
That is a rounding error on HS2. Um, the reason why you're able to access huge finance opportunities in other sectors is because there are sophisticated financial instruments to fund the infrastructure projects. I don't think we really see that in anything to do with the circular economy. It's not an area I'm specialized in, but that's the signals that I'm getting from the people who are kind of leading the space. And so I think just the funding is um, a big area which like limits the sophistication of the recycling sector because you've got very high price volatility in plastics. combined with quite difficult access to capital. Um, and I think that if we're not talking grants, but we're talking underwriting or smooth mainstreamed access to finance, that would probably help the recycling sector quite a lot. And I would say those are two significant challenges um, that the recycling sector faces.
Mm. It's really interesting. And talking of which, how is it? How is your progress going with Circular 11? I know that you have a sort of a warehouse, um, but how much have you scaled up? I'll definitely attach some links and some pictures of your products in the show notes. But how has your progress been over the last couple of years, and where are you now?
Yeah, thank you. It's been a funny couple of years. It's been a wild ride, but we were just deploying a kind of prototype facility 2 years ago. Um, and we've maxed out our facility now, and we're just in the process of moving to a much larger one. It's 11 times the footprint, so it's a big jump up for
Wow.
us. To execute on that fully, we're finishing a fundraise, and there are a few things which are contingent upon that. But in general, I think we turned a bit of a corner. It's all about economies of scale in manufacturing, and I think what's really important is accessing those larger markets for
Mm.
materials, which are very price sensitive, um, but which are really going to define the kind of trajectory of a commodities business, which in its essence this is. So it's been a really good 6 months, although a stressful one because we pivoted quite a lot, changed a lot of our pricing, changed the kind of customers we were selling to, and then unlocked a kind of new side of scale. But we're very much in the early stages of that.
Mm.
So we're still a startup and we're doing our best to kind of manage the finance needs and everything else that comes with scaling.
Well, it's incredibly impressive what you're doing, and yeah, really interesting to speak to you about this. I feel like I've learned a lot about about what's obviously a complex topic. I just wanted to ask a final sort of difficult question, but which is something like more broadly on the I suppose the sort of brand image, if you like, of plastic and plastic use. You know, it's a bad rep that plastic has. Um, Obviously, especially virgin plastic. Um, What's your sort of view? What would your sort of advice be if you were to take the political position for a second on people buying recycled plastic products? Should people be looking for non-plastic products anyway? What's your sort of view on that?
That's an extraordinarily difficult last question. Um,
Thrown
and
it at
it's
the
a,
end.
and it's a good question. We came into this not because we love plastics, but because we were um, energized by the issues associated with their end of life. So we have no interest in being an apologist for plastics. There are nonetheless um, some areas in which I often feel frustrated by uh, a lack of nuance in um, popular discussions about the material. Um, the first thing to say is I think most discussions, if they are uh, environmental in nature and empirically grounded in ambition, should be um, grounded in life cycle assessments. And I'm not a specialist in LCAs, um, and they can be quite impenetrable and quite complex. But these are reports which are done um, ideally by professionals, which looks at the range of environmental impacts from land usage and water usage to toxicity, potential contribution to eutrophication and carbon and energy from a range of factors. So they're multidimensional. And if you look at a lot of reports on, for example, replacing um, plastic bags with paper bags, it's often very surprising because you
Mm,
have to use a paper bag a lot of times, often more times than it's feasible, to have a lower carbon impact than a very thin LDPE layer. They're very, very energy efficient. Um, Even processing pulp takes a lot of chemicals. It has a lot of water usage. There are a whole range of industries on which you might not necessarily want to replace a plastic bag by a paper bag, certainly less so with a cotton fiber bag. Um, at the same time, plastic bags uh, lack a very good end market. And if you know it's going to incineration, then where does that
Yeah.
leave you where cardboard can be? So there are very complex way-offs between carbon, energy on the one hand, and circular economy on the other. So for me, well, if you lessen the incineration, and you increase the ability for us to use lower value plastics again and again, then for me, it's many times the balance tilts in its favor because of its kind of superior performance and a
Mm.
whole range of indices. Um, you know, it's an incredible material. It's an amazing material, and it's so lightweight. It's very tailorable. You can tailor it to so many different applications. If you look at the alternatives, um, they're often heavier and can't be used as easily. Um, and yet there are times where plastic may not be the right material. Certainly, I'm interested in plastic alternatives for some thin film applications, like seaweed-based materials. That would be amazing. Um, and there are certain plastics like PVC, which has chlorine in it, which I would really love if there was less of. They're very complex and often slightly harmful plastics. So, unfortunately, most of the time the discussion is about plastic as a category.
Yeah.
And it's really difficult to give a good answer. Whereas, um, the more specific the question, the more grounded the answer can be. It's like saying, is Dickens the best novelist? Well, it depends on what you mean by the best. It depends
Yeah,
on
yeah, yeah.
what values you put on that. And I
No,
think
I
in
think that's
general,
really helpful. Yeah.
yeah, exactly. If it's directly comparable to a seaweed-based film novel packaging material, maybe I'd rather the seaweed, but I'd have
Yeah.
to look at the LCA and go from there. And I think
Look at the
that's
life cycle assessment. Yeah, that sounds like a great piece of advice to end on. It's very interesting to hear that. We're out of time, unfortunately, Ben, but thank you so much for joining the podcast. It was really interesting, and yeah, thank you so much.
thank you so much. It's been a pleasure.